Alrighty, it is speed run time of the questions for homework. First off, a particle moves on the hyperbola x times y equals 18 for the time t is greater than 0. At a certain instance, we are given y and we are given dy, and I want to find out what's true about x. Looking at the answers, this is all dx dt, so I want to find dx dt essentially. To find what the derivative of x is with respect to time, I'm going to have to derive this function. So I'm going to do that up here. So xy equals 18. Derivative of the left, we're going to have to use our beautiful product rule. So derivative first, first d second, so dy dt plus second d first. So I've x'd dy dt plus y dx dt. I could plug in my 6 and my 8. So I'm going to have 8x plus 6dx dt. And I have almost everything that I need, except for this x. How could I get this x? We're going to have to refer back to our original equation. How could I solve for just this x? Well, I already have y, so I could just plug it into here. So x times 6 equals 18, so x is equal to 3. So I've solved for my x. I'm going to get 24 after I plug in 3 here that I got from here. Plug in 3, get 24, plus 6 dx dt equals 0. When I solve for dx dt, I'm subtracting 24 over, so negative 24 divided by 6, or negative 4. So I'm decreasing by 4 units per second. What we have to notice here is basically I was missing this x, couldn't solve. I need to problem solve how to find that x. I know I have an x in this equation, so I could go ahead and solve. So, looking at the next, we are talking about a cylindrical shape, and it's being stretched. We have 2 millimeters for the radius. We have 20 millimeters for the height. We have the radius is decreasing at the rate of 1 millimeter per second. So this is my dr dt. And then my height is 3 millimeters per second. That's increasing. So this is dh dt. I have all 4 things that if I were to derive this equation, all the 4 things that would pop up, I would have r, I would have dr, I would have h, and I would have dh. I have all those 4, so I don't have to worry about going back and finding anything, so I could just derive this no problem. Like up here, I didn't have the x, so I had to go back and think about how to get that. I don't have to do that here, so I could just go ahead and derive this. Even though it's going to be slightly messy, we could go ahead and do it. We're going to remember that these 2 things are functions and that they're being multiplied, so I'm going to have to use the product rule. So, on the right, also we should analyze what we're solving for. We're trying to find which of the following statements is true about the volume at this instant. When we're talking about instant, we could also look at the answers and see that we're trying to get dv dt. So, I know I'm going to have to derive the volume on the right. So dv dt, I'm going to just disregard the pi for a second. I'm going to have first d second, so dh dt, plus second d first, so I'm going to have the 2r for the derivative of 2r, and then because I got to use the chain rule, dr dt. I have all of these numbers. I'm going to have pi. The radius was 2, I believe. 2. So 2 squared. I remember dh was 3. My height is 20. There's a 2 there. There's a radius of 2. And then let's just pay attention to the fact that we're decreasing. That means we're going to be negative. So negative 0.1. There. Doing all this math out, I'm going to get pi times 12. And then this all multiplied is going to get me negative 8. So I'm going to get 4 pi. So I'm increasing, because it's positive, by 4 pi cubic millimeters per second. Now, I'm going to shrink this and put it up here, because this next problem is going to take lots of space, as you've probably seen. So there's two separate things that we need to do. Reading the problem, first let's just read the problem and kind of analyze what my thinking is and what your thinking should be. So a model car is moving around this track. This radius is 5 feet, so that's going to be something important to note. Z is the distance here. So it's distance from this point here to wherever the car is. The center of the track is at 20, 0. Now, if x and y are functions of time, what is the rate of change of z? Okay, so let's keep that in mind. We're going to find dz. It's in all the answers. So dz dt, when x is 23, y is 4, and dx dt is 2. Looking at this, I don't see a dy dt. Can we think of a way that we are going to be able to find a dy dt? I'm going to go ahead and use their hint here. Let's think about what these variables are. The h and the k, that is the center of the circle. So that's 20 and 0. Those are literal numbers. I have x, I have y. When I derive this function, guess what's going to appear? My magical dy dt that I need, and a dx dt, which I have. So I'm going to get a whole bunch of numbers and a dy dt. This radius is also just a number. It's going to be 5. So I could go ahead and set this up here. So I want to use the pretty pencil. X minus 20 squared plus y squared. So 20 is the center, so I have minus h, so it's minus 20, minus 0, so I just put y squared, equals 5 squared. When I derive this, I have to be very careful that I also put in my dx dt's and my dy dt's. So deriving the first term, I'm going to get 2 times x minus 20. That's actually the derivative of this. It's kind of funky because the derivative of the inside is just 1, and there's no other power. It's kind of weird. But since I derived the inside and there was an x, I have to have in this dx dt. Then I'm going to have 2y dy dt, then 0. So I'm going to have 2 times 23 minus 20, dx dt is 2, plus 2, and I think y was 4. So times 4 dy dt equals 0. So this is 2 times 3 times 2, which is 12. So I'm going to get negative 12 over here, times 8 dy dt. dy dt is equal to negative 12 over 8, or negative 3 over 2. Now, so I did this with a lot of foresight in mind because I've done this problem earlier today. I just wanted to make a video about it, me going over them, just so you have it in your data bank. So this was with a lot of foresight in noticing that we don't have dy dt. We're not done with this problem because I still got to find dz, and I'm going to show you kind of where you might fall into this pitfall. So z is the distance, so I'm going to need to use the distance formula. So z is equal to the square root. Now I'm finding the distance from a point to 0. All it's going to be is x squared plus y squared. So it's going to be really easy. I'm going to rewrite the square root as a power to the 1/2 though. Make it a little bit easier to think about. Deriving, lots of fun. On the right, dz dt. And on the left, deriving the inside, 2x dx dt plus 2y dy dt. Now I got to derive this portion, or I shouldn't say that. My bad. Let's rephrase that. I leave the insides, and then I bring down the power. Instead, what I'm going to do is I'm just going to chuck this down here. I want to make that look a little bit nicer. I'm going to erase the negative and make it a fraction. So if you were to do it this way and you did this portion first, that's grand. And what you would have noticed at this point is you're about to plug in all these numbers, and you're like, shoot, I don't have a dy dt. I have one unknown, and I have two unknowns, and I only have one equation. So I need to find another equation that's going to link in that dy dt, and that's where this comes in. So now I can just go ahead and plug in all of these wonderful stuff. So, no, I want the pencil. 2, forgot what x is. 2 times 23 times 2 plus 2 times 4. Dy dt was negative 3 over 2 over 23 squared plus 4 squared, and we're taking the square root of that. So this is going to equal to, oh goodness gracious, it's something minus 12. I think it's 92. Does that sound right? Think about it. 2 times 23 times 2. Yeah, we're good. So 92. Oh, shoot. No, where's the other 2? Oh, I didn't bring down the 1/2. I need to bring down the 1/2. Oh, no. There's a 1/2. So what I can do is I can write a 2 on the bottom. 2 times the square root of 5. What's the number? 545. So I'm going to get 80 minus over 2. And then the square root of 545. So I'm going to get 40 over square root of 545 as my dz dt. So what is my answer? So are we moving away? So let's think about this. I have 2 answers, B and C, that both have what I got as the answer. So is my model car moving away, or am I moving closer to the point? Well, let's think about it. We can analyze this just by thinking about whether this is positive or negative. This is positive, meaning my change in my distance is getting bigger. If I'm getting bigger, there's no way I can be going this way, because if I'm going this way, I'm getting closer to that point. If I'm going this way, I'm getting further. So I have to be moving further away at B. Sorry for this mishap here with that 1/2. My bad. Shame on me. This is a really complicated problem. I think this is probably about the extent that I would go. I think anything harder than that is quite clinically insane. Anyway, let's move on. We got a few more things. This C is quite an interesting little problem, and we're going to get to it. So the first thing I want to do is find the volume of water when the container, the height in the container is 5 centimeters. So there's a few things that we've learned about the cones is that the H and R are proportional. So we're going to need to use those ideas. Also, for reading, the water in the container is evaporating, so the depth H is changing at a constant rate of negative 0.3 centimeters per hour. So that's our dH dt. How our height is changing with respect to time. The height is 10, and the diameter of the opening is 10. So meaning, let's not fool ourselves here. That means our radius of the whole container is 5. So with the 5 and the 10 here, I want to know when my height is 5. So I know, based off the fact that my height is 10 and 5 is my radius, that my height is 2 times my radius, or, depending on which way you want to look at it, my radius is 1/2 the height. So, in finding the volume when this is all going on, A is going to be, I just plug in that radius that I found into here. So it's going to be 1/3 pi, r is 2.5 squared times 5. So I have no idea what 2.5 squared is. 2.5, hold on, 2.5 times 2.5, holy, let's do this better. Let's do this the smart way. Let's write it as 5/2. Now it's easy to handle. Because what I'm going to get, no, pretty pencil, is 1/3 times 5/1 times 25/4 times pi. So this is just going to be 125/12 pi. Because it's in volume, I'm going to be in centimeters cubed. Let's be careful about our what we're trying to find and our units. Very important. Find the rate of change of the volume of the water container with respect to time when h equals 5. Okay, so let's think about this. So rate of change of the volume is dv dt. That's what I want to find. Now, I have dh dt, so if I can write this whole entire thing in terms of just h's, that would be awesome. I know how to do that. I have the fact that r is equal to 1/2 my height, so I'm going to plug in that for here. So let's go do that below. So B is 1/3, let's actually write it all out. So my volume is 1/3 pi r squared h, but I'm going to rewrite that r squared as 1/2 of the height squared. I'm going to write it as h/2 actually, so it looks prettier, times height. So now, as I simplify this, before I derive it, I want to get it as nice and as succinct and simple as possible. I'm going to have pi/12, 3 times 2 squared. That's where the 12 comes from, and I just move the pi up top. And then I'm going to get h cubed. Simple as that. That's with respect to my volume, or equal to my volume. Taking the derivative of both sides, dv dt. So I'm going to bring down to 3. So 3 pi/12. What does that change into? 1/4. So I'm going to change that back to a pi/4. H squared dh dt. So I have dh dt, and I will have the height is 5. So pi/4 times 25, because that's my height squared, and then dh dt is -3/10. So -3/10, 25/1. We just do some multiplying straight across. I'm going to get -75 pi over 40. Both of these are divisible by 5, so I'm going to get -15 pi over 8. Let's make sure our units are right. So find the change in the water volume of the container. So I'm dealing with water volume. You could have the units in this throughout. I think it's really hard to do it like that. So I'm just going to put centimeters cubed per, what are we dealing with here? What's our rate that we're leaving? Per hour. Per hour. Okay, so lastly, show that the rate of change of the volume of the water in the container due to evaporation is directly proportional to the exposed surface area of the water. So this is something crazy. So rate of change of the volume, so this is dv dt, which we have found. Let's write that down here. So that's the rate of the change of the volume of the water. Is directly proportional to the exposed surface area of the water. What is the exposed surface area of the water? So the exposed surface area of the water, if we zoom out and look at our picture, or not, it's just whatever the radius is. So my surface area is equal to pi r squared. So if I look, all of my stuff down here is in H. So I have H's, I have H's, I have H's, I have H's. And now I'm bringing in this random R. I'm going to have a little bit of a tough time dealing with the numbers if I'm dealing with radiuses and heights. So what I'm going to do is do the same thing we did earlier and bring that H down into it. So I'm going to get my surface area is pi times H over 2 squared. So it's going to be pi over 4 H squared. So now, it's asking for the constant of proportionality. So basically, what I'm looking for is it's going to be my surface area times something equals my dV dt. That's essentially what it's asking. This number here could be a fraction, or I could be multiplying or dividing. Either one's fine. So all I need to do is look through and find, oops, what did I just do? No, what happened? Where's my pointer? Oh, whatever. Is I need to find this, and I can see I have that right here. So it's surface area times dH dt. So literally, my constant of proportionality is that -3/10. So I know that my, ugly pencil. I know that my surface area times -3/10 is going to equal dV dt. So I know that my constant of proportionality is -3/10. So I don't know when I'm going to put up this video. I don't know if I'm going to put it up tonight after school or tomorrow after school, or I guess I should probably just say the day, Thursday after school, or wait a little bit longer. I do want to kind of discuss some of these problems, but I also want to make sure I give you guys a fair go at them. I really hope that you guys are able to do number one on your own. I expected before this video to go out that I was hoping that you guys were able to get number one and number two on your own. Number three is pretty hard. I'm not going to lie. That's probably about the extent that I would go. Recognizing that they give you this formula, but you're going to have to come up with this on your own, or recognize the fact that this is a distance, and then to use the distance formula is not the easiest thing in the world. Finding A is not bad. We just had to think about what that number in here was going to be. And then finding B wasn't bad too. This constant of proportionality is something that's slightly obscure and kind of a random question to ask. Basically, all we're trying to do is relate our surface area to our dV dt in some way. And you could see that right here, this is essentially saying dV dt equals the surface area times dH dt. So, because that pi over 4 h squared is there. So, Hope this helps.